I wanted to do was define what a linear equation is, so we knew what we were focusing on this chapter. And so we can differentiate it from the future. Linear means that x is to the first power. So when we are looking at solving, you won't see x to the second, you won't see the square root of x, you won't see any of that. You're only going to see x to the first power. General is just kind of I don't know why I need that adjective in there, but. And before we take our first assessment, we're going to focus on equations first, and then we're going to do inequalities. Because inequalities is a different skill than equalities. So inequalities is when we'll focus on greater than and less than. That becomes a little more challenging, especially when we talk about absolute value. That is can be very challenging. So we're going to split that up into two different sections. Sorry. That's part of what I'm talking about. Okay, so the additive and multiplicative properties of equality are kind of what we were talking about in the entry problem. It's the ability to add the same number to both sides and multiply or divide the same number from both sides. And I'd like you to get in the habit of showing your work similarly to how I show my work, because some of the habits that students can get into really are detrimental in terms of showing work. So it's a vertical way. So for example, for this one, you're going to add 7 to both sides, but notice I'm showing that vertically. I'm not lining it up on the same line as the original equation. I'm putting the plus 7 below. And so the reason I add 7 is so it cancels out the minus 7. And again, the goal is always to isolate the x so you can find out what x is. So I get 2x, and 0 plus 7 is 7. And then now we can use the multiplicative property of equality. You can think of that as multiplying both sides by 1/2, or in other words, dividing both sides by 2. And as long as we do the same thing on both sides, it's fine. Now in Algebra 1, as is in almost every math class going forward, you're going to want to leave your answer in reduced improper fraction form. So 7/2 is reduced, and you're going to want to leave it as an improper fraction unless it's a word problem. So if these were like the number of pieces of lumber, we want to call it 3.5 pieces. But if it's just a regular math problem, you'll leave it as 7/2. Yes?
Why would you leave it that way?
Because when you do math with this, it's easier to multiply and divide fractions if they're as an improper fraction. It also tends to be easier to add and subtract them if they're like this. So that's why we keep them as an improper fraction.
And also, another question is, like, will there be any time when we would have to, like, re-plug in the answers, like, if x equals, but we have to re-plug it in each other?
Yeah, so this whole checking of work thing is always important, especially in a test situation when you don't have like a back of the book. So like 2x minus 7 equals 0. Watch this when I'm checking x equals 7/2. If I plug in 7/2, it would be 2 times 7/2 and then minus 7. Does that equal 0? Well, watch this. If I keep it as an improper fraction, do you guys see how the 2's cancel? And then it's just 7 minus 7 equals 0, and then you're done. So it's an easier process of checking as well.
Wait, couldn't put like anything that, like any problem that's equals 0, 0. It to be like, say it's like 2x minus 8. Could it then just be in parentheses 8 over 2?
It could be, but that one we'd want to write as 4 since it is a whole number.
Oh, okay.
So if it's in, if even when you reduce it, it's in decimal form, you believe that's a fraction, but if you can reduce it and get a whole number, you put it into a whole number.
Right, whole numbers, you always want to have a whole number.
Okay, thank you.
Sure. So this one, you have a +1 to a -1. Do the opposite operation. So then we get negative 4x is, what is this one going to be?
Negative 12.
Good, negative 12. Now we divide both sides by -4 or +4. -4, because you have to get x by itself. So if you just divide by 4, you won't be getting x by itself. Negative divided by a negative is a positive, so x is going to be 3. Okay, and again, if you're in a test-like situation, you would check it. You plug it in, make sure the left side equals the right side. And you can do a quick check if you wanted. Negative 4 times 3 is negative 12. Negative 12 plus 1 is negative 11. Yes?
Is there ever going to be like a point where you're going to checks
I never make you. It's just like, do I have time left? Yes or no? And if I have time left, you're going to want to do that. There will be tests that are so long you won't have time left, but at this point they won't take you the whole hour, so that's when you're going to want to maximize. Like your algebra grade is August through May, and what you get now when it's easier is going to be great to balance out when it's harder. Because you're going to get to the point where everyone's like, oh my gosh, it's so much harder. You can talk to everyone who's at the class, it always happens to them, and it hits them in the face. So that's where you want to maximize your score at this point. So we have a +7, so we want to subtract 7. And then we'll divide by 3 to isolate our x. And since this is a whole number, we will divide. Notice I'm showing my work vertically. I'm not putting the -7 on the same line as the original equation. Yes? How would you do it?
Like, I'm doing 25 plus negative 7.
So eventually that is going to be bad. It's just going, especially when we get, you're going to have 2 equations with 2 variables. It's just going to get to where that is no longer going to be a good idea. So that's why for these easier ones, I'm trying to teach you a new habit. Logan?
Do you always multiply or always divide, or when do you normally do?
I will show you momentarily.
Okay.
So if it is 3 times x, the opposite operation to multiply is divide.
Okay.
So that's why we were dividing. If you had this problem, x divided by 3 equals 5, what's the opposite of dividing?
Multiply.
So this is where you multiply both sides by 3.
Then you get 15.
Yeah.
Oh, okay.
So it's always, you're undoing what is being done.
Okay.
Okay, let's look at this one. We have 1/2 x minus 4. So instead of subtracting 4, what are we going to do, Damian? Add 4. Good. So we get 1/2 x equals 21. Now, when there's a fraction, you really don't want to think about dividing fractions. Multiply by the reciprocal. Good. So the reciprocal of 1/2 is 2/1, or 2/1. Now, when you multiply by the reciprocal, make sure to line up the numerator with the numerator. This one doesn't have a denominator, so it's gonna be 1. So on the left side, the 2's cancel, the 1's cancel. That's why we do it. So you have an x, and here we get 42. Or 42 over 1. Any questions on that? Isaac?
Would you show that there's numbers like on each side them?
Numbers where?
Could you do it like human like horizontally there?
Yeah, if you're multiplying, you really have to go horizontally because you don't multiply vertically once you get to algebra. That's a good question. All right, bye guys.
All these?
Oh,
No.